Yep. Hello, everyone. In this video, I'm going to this is a very short video in which I'm going to just explain the assumptions of DGR, which is the dynamic general relativity. So I'm Rohit, and I'm author of this book, Decoding Gravity, Time, and Causality. And in this book, I've described what is called as dynamic general relativity. This is a new theory of quantum gravity and a potential theory of everything. Now, as soon as someone hears the word potential theory of everything, the first thing which comes to people's minds is that, oh my God, this must be some exotic theory with multiple hundred assumptions, and it will be extremely complicated and full of mathematics, and I won't be able to understand it. Just forget it. I just don't want to even listen to it, even think of understanding it. So this is basically the first psychological response of thinking or you're listening to such a term of theory of everything. Oh my God. So the only intention of this video is to give an idea of why this particular theory is so simple that it's absolutely logical. It's based only on logic and nothing else. So there's not much mathematics also in it. It's absolutely based on logic, and the logic, there are multiple assumptions basically, but the most important assumptions are three, or you can say four assumptions. So these four assumptions, how you can, within a 5-minute video, you can derive those assumptions, how they can be derived. And that is how, that is what is I'm going to explain in this very short video, hopefully a short video. So this is the book actually, Decoding Gravity, Time, and Causality, Dynamic General Relativity. Okay. So the first assumption, we'll go to the first assumption. Any apple or any object which is gravitating downwards, we are absolutely sure that as soon as you leave the object, it falls down. When it falls down, we know that just beneath it, if you have a unit of time, if you have a unit of space, let's say 1 cubic meter or 1 cubic centimeter or anything like that, then we know that if you draw a skyscraper of such a thing from that particular object to the surface of the earth, the number of cubic cubes of this 1 cubic millimeter will keep reducing as time progresses. So at this one particular moment, there were more number of cubic cubes here, but as the time progresses, the number of cubes reduce. So basically, there is a loss of volume which is happening just beneath the particle or whatever, the apple or ball, or for that matter anything which is actively under gravitational influence of the earth. So there is active loss of volume. So the first assumption is what? Space can actively contract. Space can actively contract. The second assumption is what? Of course, we know that Hubble said that if there are two galaxies which are not gravitationally bound, with time the distance between them increases, that is the space in between is expanding. So the second assumption is simple: space can actively expand. So there are these two assumptions are very simple. Now how exactly we need to put them into perspective is the Planck scales and all is not very important actually. The most important thing what it is that space can actively expand and space can actively contract. So for space to actively expand, what is needed is units of space have to be actively created from something, and for space to actively contract, units of volume has to be created, has to be destroyed basically. So if there is destruction as well as creation, there is a basically one implication that probably space can theoretically remain stable without any active expansion or contraction. But if active expansion and active contraction is possible, and also space can theoretically remain without active expansion and contraction, then basically what exactly is happening there? So at the most basic level, active creation and active destruction has to happen basically, and the active creation and destruction can remain stable, so equal. So if the active creation and destruction is remaining equal, that causes the space will remain stable. And if either of the processes is more, that is, if destruction is more, then active contraction will happen. And if there is a creation is more, then active expansion will happen. So it's very simple basically. These two assumptions are there's nothing in controversial about them. So active expansion of space is possible, active contraction of space is possible. But we know that if there is an active any place where there is active spatial contraction, like just beneath the Newtonian apple, there is active contraction of space. So do we see any void anywhere? So if there is active contraction here, is there any void or empty space? No, we don't see any empty space, which means what? If there is active expansion or active contraction, then there has to be some compensatory mechanism. So this is again another third corollary, is that if there is active expansion and contraction without any void which is visible, that means that there has to be a very good compensatory mechanism which compensates for this active creation or destruction. So if there is a destruction which is happening a lot, then there has to be some compensation, because we don't see the void. If there is a particular destruction going on at one particular particle, then the surrounding area has to basically react to that destruction and avoid the void from getting formed. So if there is a lot of destruction and void, then we would detect the void, detect that kind of a void. So there is some kind of compensation. So these are the two basic assumptions of, these are basically electrons. If there are two electrons which are coming close to each other, we know, forget about quantum electrodynamics and all, but we know that these two electrons will repel each other, or for that matter, two magnets. If you take two magnets, they will basically, what they'll do? They'll repel. If a proton and an electron comes, they will attract. So there's no problem about this, that we know that attraction happens and repulsion also happens. So what is there is another implication of the first and second assumption, that attraction is basically, if there are two particles which are getting attracted to each other, it means what? It is active spatial contraction in between them. But we know from classical electrodynamics that there is not, the force is not completely surrounding the charged particle, but there are small lines of forces. So these lines of forces are there. So this active contraction of space, which is happening between one proton and one electron, active contraction of space, these should not be all around the particles. It should be a small corridor of active spatial expansion. So repulsion is exactly the same, but opposite. This active spatial expansion should happen in between an electron and another electron. So if they are coming close to each other, there should be a corridor extending from one charged particle to the other charged particle, which is basically causing active spatial expansion, and it's causing repulsion. So these first and second assumptions, they hold true for us to explain the active repulsion or attraction of the charged particles. So what is the third assumption? Basically, it's related to time, or maybe you can say third and fourth assumptions are related to time. So what will happen if there is active spatial expansion, or rather active spatial contraction? So this is basically what? A photon clock, and this is a photon, and these are two mirrors, left mirror and right mirror, and the photon clock is basically ticking. The the photon is traveling from left to right, and then it will go from get reflected, and then it will keep going like that. So that's what is the one tick of the photon clock. That is the photon reaching from left to right, and then again going from right to left is one tick. Maybe you can say per journey from left to right or right to left is one tick, whatever. So what will happen if there is active spatial contraction just before the photon? So it will hinder the forward progression of the photon. It will reduce the velocity of the photon. So active spatial contraction is what? There is more destruction than creation. So there is a lot of processes going on. There is more destruction than creation. Creation is also going on. Destruction is also going on in the quantum Planck scales. But the destruction process is much more than the creation. So there is active spatial contraction. So if there is active spatial contraction, what is happening is slowing down the ticking of the photon clock, or slowing down the velocity of the photon. So active contraction of space just before the photon causes what? Reduced velocity of the photon. That is one thing. And second is illusionary local time dilation. So basically there are two types of time. So there's one time which is absolute, and there's one time which is relative time. And then this relative time is basically illusionary time. And illusionary time is because of what? Reduced velocity of the photon. So DGR says that actually speaking, C is not constant. So C is variable. And wherever C is varying, there is active spatial contraction or active spatial expansion. So what happens if there is active spatial expansion just behind the clock? Simple, that the active spatial expansion will push the photon forward. So what will happen is the ticking of the photon clock will be increased. So there will be speeding up of the ticking of the photon clock. So what will happen? Essentially, what is happening is here is that there will be an illusion of a time contraction. It's an absolute illusion, so you just cannot make out whether this is a real or a illusionary. But any time apparatus of ours will show speeding up of a clock. So the speeding up of a clock is basically time contraction. So anywhere where there is active spatial expansion happening, there will be speeding up of the photon clock. That is, there will be a illusionary time contraction. So what is the third assumption? What is the fourth assumption which is comparable to the third assumption? Active spatial expansion just before the photon clock causes an increased velocity of the photon, and also illusionary time contraction. So illusionary local time contraction and dilation, like that. So this should be contraction, this should be time contraction, illusionary local time contraction, not dilation. So like that, these are the four assumptions basically. So, and what is another implication is that time is absolute, and that whatever relativity of time which the relativity is saying, both general and special, is actually relative illusionary variation of time because of variation of the velocity of the light. That is, c, or the velocity of light, is not constant, but it is actually a variable which is varying with respect to active spatial expansion and contraction. So time dilation that we see here on the surface of the earth, which is actually gravitational time dilation, is actually because of active spatial contraction which is happening near the surface of the earth. So more is the active spatial contraction, more is the time dilation. So nearer to the surface of the earth, there is much more active spatial contraction, and very much away from it, there is much less active spatial contraction. So this is the basically some of the assumptions actually. So the theory is very simple, and the assumptions are also not very difficult to understand. And so if you think that there is a proton and a neutron and an electron, so they keep getting attracted towards each other, and then they stop. So why should they stop? Well, there's still attraction going on. Some corridors are there where there is active spatial contraction, but then there will be some corridors where there is active spatial expansion as well. So expansion, counterbalancing, contraction. So there is some time when there is contraction, but at the same time there is some other corridor where from where there is expansion also. Contraction, expansion is counterbalancing to each other. So that is how the electron will stay in the orbit or stay in atomic orbit, first orbit or second orbit or whatever. So like that, you can explain why the electron doesn't keep falling into the proton. Like that, everything is explained on the basis of active spatial contraction and expansion, and how much is the active spatial contraction or expansion. Depending on that, there will be a variation of time dilation. So in a way, even all the force carrying particles of quantum mechanics are also time dilation or time contraction, depending on active spatial expansion or active spatial contraction. That is how it basically reconciles quantum mechanics and general relativity. And so if there is if you want to say about quarks, so what happens is there are quarks are also charged particles, so they will have a varying time changes all around it, and these time changes will have corridors of active spatial expansion and active spatial contraction. And this if two quarks are attracting each other, is what basically there are corridors from one quark going to the corridor of the other quark, which is causing active spatial contraction. Now this is not as simple as it is shown over here, but it remains the same. Basically, this is an absolute a theory which is based completely on logic. So there is no there are no it's not it's based completely on logic, and it's a realistic theory. So so an electron is a real particle, and it has a particular position, and it is a realist theory basically. And it is, so to summarize, basically it is a realist theory, and also it is a theory which is based on variable speed of light, that is VSL type of theory, VSL type of general relativity. So thank you very much for your attention, and I hope that you have understood a bit about it. And if you want to go more into details of what exactly it is and what theory it is and all, you should go through the first or the introductory video, which is a bit long basically, but I have explained these spatial assumptions and time related assumptions in much more detail in that. So you should go through that, and you should go through all the other videos as well. And also, of course, you should buy the book and go through the book, because in the book that it will be in much more detail. So thank you very much, and have a nice day.